Good evening. My name is Abhinav Sharma. Today I am presenting KageMei, a privacy guardian for your Android device. KageMei monitors how every app on your phone accesses your camera, microphone, and GPS and alerts you the moment something suspicious happens. Think of it as a security operations center right in your pocket. So let's get started. So here is one question that do you know which app last accessed your microphone or when your camera was used in the background? Exactly, none of us do. And that's the problem. Android's permission system is broken in one critical way. It grants access at install time but gives you zero visibility into when that access is used. So we identified three specific gaps. First, no visibility. You have no idea which app is touching your camera or microphone right now or whether it's happening in the background. Second, no alerting. There is no native Android notification when an app accesses a sensor unexpectedly at 2 a.m. while your phone is sitting idle. Third, no audit trail. There is no history you can review, no log to share with IT security, no evidence when you suspect something is wrong. These are not hypothetical threats. Apps have been caught doing exactly this. And our solution, that is KageMe, closes that gap. KageMe is a purpose-built Android security application. It runs continuously in the background with zero root access required. There are four things that make KageMe different. Number one, real-time monitoring. A foreground service polls sensor activity every 30 seconds across all installed apps. Number two is smart anomaly detection. A rule engine flags suspicious behavior and it learns your personal patterns over 7 days to reduce false alarms. Number three is AI-powered explanations. When something suspicious is flagged, a cybersecurity tuned language model explains it in plain English. And number four, no root, no cloud, everything stays on your device. So this is your security operations center in your pocket. Now let me walk you through how Kagami works under the hood. The architecture follows a clean MVVM architecture with 5 tiers. At the bottom, the OS interface layers talks directly to Android APIs, which are App Ops Manager, Usage Stats Manager, and Package Manager. Above that is the service layer. This is where Privacy Monitor service lives. It is a foreground service that runs a coroutine-based polling loop every 30 seconds, and a boot receiver ensures it restarts automatically after a device reboot. The data ingestion layer handles telemetry capture, deduplication, and persistence to a room database. Then is the intelligent layer. Our anomaly detection engine scores every event and adapts to per app behavioral baseline over 7 days. Finally, the presentation layer. 5 view models feeding a Jetpack Compose UI and an LLM integration via Olama. Data flows in one direction from OS signals to the pipeline to the UI. Now at this slide, you can see how data actually flows to the system from your device all the way to your screen. So at the very top, we have user and the device. This is the starting point. The user interacts with the Jetpack Compose UI, which is organized into 5 tabs: the main dashboard, telemetry, alerts, audit, and the explain view. Each tab is backed by its own dedicated view model, so the UI is always reactive and never blocks. So when the device boots up, a boot sorry a boot receiver fires immediately and starts the privacy monitoring service as a foreground service. This service runs a coroutine-based loop that polls every 30 seconds continuously, even when the app is closed. The service is also connected to a notification helper, which is responsible for dispatching all alert notifications to the user. Once the service is running, it needs to collect data. That's the telemetry ingestion here. Here we have two paths. The first is the confirmed path. The service queries App Ops Manager directly. App ops gives us precise timestamp records of exactly when each app accessed the camera, microphone, or GPS. This is the gold standard highest confidence data. And what here is the reality on most Android devices, third-party apps cannot query app ops for other packages. So we have a second path, the inferred path. When confirmed data is not available, the service falls back to the usage stats manager to find recently active apps, then cross-references package manager to check which sensitive permissions those apps hold. If an app was recently active and has camera permission, we infer a likely camera access. Both paths fits into sensor repository, which is a single source of truth for all telemetry. From there, this data moves to the intelligence tier. Sensor repository passes every raw event to the detection rule engine. The engine also receives two additional inputs. The user configured quiet hours and a 7-day behavioral baseline it has built for each app. Using these three inputs together, it scores every event with an alert level: info, medium, high, or critical. An event that would normally be high might be demoted to medium for an app that regularly uses the microphone at night because that's its baseline. So all scored events are written to storage, a room database with three key tables. The sensor access stores individual sensor access events, one row per detected access. The app summary maintains a running app sensor summary per app, aggregated counts, background ratios, and a risk score from 0 to 100. And the watchlist stores any apps that the user has manually flagged for elevated scrutiny. Finally, we have AI layer, this one. So the AI layer takes a single sensor access event and sends it to the locally hosted LLM, asking it to explain what happened and why it matters. Uh, it takes an app's full permission posture, its summary statistics, and recent high severity events and asks the LLM to produce a structured security audit report. So these LLM calls go to a local Olama server. So to summarize the full flow in one sentence, the device's OS signals are captured every 30 seconds, scored by an adaptive intelligence engine, persisted to a local database, and surfaced to the user through a reactive compose UI with an AI available to explain every single event in plain English. So that's the complete architecture of KageMei. Now KageMei has six core features. Let me run through them quickly. First is dual telemetry. We use a confirmed AppOps path where available with an intelligent fallback to usage stats plus permission analysis for stock devices. 4-level alerts. Every event gets scored as info, medium, high, or critical as discussed during the architecture workflow. Background camera or microphone access always triggers critical adaptive learning. The engine builds per app behavioral baselines over 7 days with quiet hours profiling so your music app at midnight does not spam you. AI explanations. Tapping explain on any event queries our cyber security tuned LLM, which returns a plain English analysis what happened, why it matters, and what to do. And we also experimented with on device only room database, no cloud, and experimental 4-bit GGUF LLM was used for this as quantized model even runs LLM inference fully on device. And finally, the SOC dashboard, a 5-tab compose UI with 7-day trend charts and heat maps. So this is next slide is about intelligence engine. So let's talk about the brain of Kagemi, the detection engine. Every sensor access event is passed through detection rule engine, which assigns one of four alert levels. Critical is the highest. Any background camera or microphone access is automatically critical regardless of app, time of day, or anything else. High covers suspicious package names in background, nighttime background access, or when an app has accessed the same sensor 5 or more times in 1 hour. Medium handles repeated background GPS, nighttime foreground camera, or 3 or more background accesses. Info is normal daytime foreground access by known benign apps, but here's what makes it smart: adaptive quiet hours learning. The user sets quiet hours, for example, say 10 p.m. to 6 am, is not active on his phone. So over 7 days, the engine builds a night profile for each app. How often it accesses sensors at night and whether that's normal for that app. So a music app that regularly streams at 2 am gets its severity demoted, it's normal. An unknown app accessing the microphone at 3 am with no night baseline gets its severity promoted. and that's the threat. This dramatically reduces alert fatigue while staying sensitive to real anomalies. So, one of KageMei's most powerful features is its AI integration. The LLM isn't a general purpose chatbot, it's fine tuned on cybersecurity data, threat intelligence reports, CVE descriptions, permission abuse patterns, and documented malware behavior. When you tap explain on any event, the app serializes the event, sensor type, timestamp, package name, foreground or background state into a structured prompt. The prompt is sent to a locally hosted Olama server, so no internet required. The model returns a plain English explanation. For example, like not just camera was accessed, but this flashlight app accessed the microphone in the background at 3 a.m. So we will see it's working at the end of the presentation. Also, for the audit tab, the user can select any app and run a full AI audit, getting a structured report with risk score, expected permissions for the app's category, anomaly summary, and specific recommended actions. And as an experimental path, we have tested a 4-bit GGF quantized model running fully on device, zero network dependency, that is complete privacy. So now let's talk about the user interface. The UI is built entirely in Jetpack Compose, modern, reactive, and smooth. There are 5 tabs. SOC Home gives you an inventory overview, active sensor counts, a risk distribution chart, one-tap refresh, and a system app filter toggle. Telemetry is your live event streams with a confidence banner that tells you whether data is confirmed via app ops or inferred. Every event has an explain button. Apps gives you a full permission matrix, camera, GPS, microphone for every installed app. Sortable by risk score. Tap any app to see a 7-day trend and hourly heat map. Alerts show only high and critical events with acknowledged controls and a badge count so nothing slips through. And audit is where the AI lives. Select one app or all, run the audit, and get a full structured report right in line. The entire UI auto refreshes within 30 seconds of any new sensor access, so no manual refresh is needed. So talking about problem statement 5 for this hackathon, it had 7 specific requirements and our proposed solution Kagemi meets all 7. Let me go through them quickly. Track sensor permissions per app done with dual telemetry paths, log suspicious activity done with the rule engine and alerts tab, alerts on background sensor access done with critical and high notifications, background monitoring service done with privacy monitor service and boot receiver, notifications for unexpected access done with per event heads up alerts, permissions audit and recommendations done with AI powered audit tab, dashboard with sensor trends and alerts done with all 5 UI tabs. So we met the 7 requirements. So why does Kagemi stand apart from anything else out there? First is adaptability. A dual telemetry path means Kagemi works on virtually every Android device from developer unlocked phones with full app ops access to locked down stock devices where only usage stats is available. We cover 98% of active Android devices without requiring root. Second is intelligence. This isn't a static rule set. The engine learns per app baselines over 7 days and adjusts sensitivity dynamically. It gets smarter the longer you use it. Third is explainable AI. The LLM does not just flag events, it explains them in the context of real cybersecurity threats. That is a fundamentally different and more useful alert. And privacy first, everything is local, no telemetry upload. The app that monitors your privacy does not compromise it. Uh, so, as you can see, Kagami demonstrates that robust real-time sensor privacy monitoring is achievable on Android without root access, without cloud connectivity, and without compromising user privacy in any way. Now, let me show you Kagami in action. So this is the SOC home screen, the first thing you see when you open Kagami. At the top, you will notice the status badge says protected in green. That tells you the background monitoring service is actively running. Below that is the app asset inventory. Kagami has already discovered 9 endpoints, meaning 9 installed apps on the device. Also, you can see these are the apps. For example, Blinkit, ClickBuzz, Him Upastiti, Olymp Trading, etc. Also, there is a warning label which says, now look at this warning when, which says if some installed apps are missing, Android package visibility rules may be restricting access. Query all packages is enabled for broader inventory visibility on supported builds. So this is KageMei being completely transparent about its own limitations. We never hide the confidence level from the user. Let's talk about screen 2, which is about telemetry. You can see here is quiet hours configuration, and user can set quiet hours from 10 a.m. to p.m. From here, for example, we have set it from 10 a.m. to 2 p.m. During this window, apps that regularly accesses sensors are treated with lower sensitivity, while apps with no established pattern this window get flags more aggressively. So this is adaptive learning in action. And for example, here you can see there is one event camera which was accessed. Okay, unable to generate explanation, check local LLM server. So I will start the LLM. So I have started the LLM, and let's see again this explain generating explanations. So as you can see, the model is running, and see it gave the reply. What happened? Camera used make in foreground. Why it matters? Needs review due to elevated alert level. Inferred based on recent users plus granted permission. Open app settings and verify camera oblique location permissions for this app. So you can see while we will press the explain button, the LLM call will be there, and it will give the full LLM analyst note. Now here you can see all the apps. For example, Himopacity has GPS on, Olympic Trading is camera on, GPS on, and you can even, if you will do include system apps, you can see all the system apps also. For example, this is we will see what are the permissions for camera. So here we can see for Bluetooth GPS is on, for calendar all the three permissions are off. If we can see the camera, for camera this permission is on, GPS is on, and microphone is on. Now in the alerts, whatever will be flagged by our detection engine will come here. For example, this camera was accessed at unusual time, camera accessed microphone at an unusual time. So here also we have given the explain button, which basically will give a call to LLM, and it will explain why this was a suspicious activity. Now coming to the audit tab, here you can select any of the app to run the audit. For example, I will say for him Upasthiti, run AI audit. So, and here is the result, a full structured audit report for the Hemopacity app. The app Hemopacity has an inferred permission posture with no strong anomalies detected based on the provided telemetry. What are the top risks? What is the recommended actions? And we can also run per app AI audit, or we can also run for all apps also. So in under 2 minutes, KageMei has shown you live sensor monitoring, transparent confidence reporting, adaptive quiet hour configuration, inline AI event explanations, and a full app level security audit, all on device, and no root permission was needed. So that's KageMei, and thank you.